All right. Welcome to your review. Coming to you late, but here it is. So your test tomorrow is talking about how the Earth was formed. And if you look here, the thing we learned about is that there was a supercontinent called Pangaea, and over the last few 100 million years, it is broken into the continents that we see today. So the question is, if this was true, because obviously we weren't around back then, how can we prove that? Well, we can prove it if we look at the fossils. So fossils are the best evidence of how our geography, which means the earth, and also how living things may have changed over time. So the one thing we're looking at here is that if you find the same fossil on different continents in today's society, that's evidence that a few million or whatever time ago that those continents may have been connected. Another one we look at is the rocks, having the similar rocks with the same chemical makeup on different continents shows a connection. Another one we also looked at was also the evidence of ice or some of the ice grooves, the glacial removes in tropical areas. So you've seen this question multiple times on your quizzes. Is finding tropical plants in areas where it's super cold, or finding evidence of ice once being in areas that are super hot. And so this idea that the earth is being changing by what you find is the clues to how the continents may have drifted over time. So the drifting occurs because of continental plate movement. And so we looked at how the divergent boundary can make an ocean trench, the convergent boundary can make mountains, and then the question about how marine fossils can be found on top of mountains is once again this area here may have been the ocean, but over the next few million years, as this mountain is pushed up, that fossil that was stuck right about here can now be moved up as the mountain grows. And so convergent boundaries can make mountains and also volcanoes. And then we looked at transform boundaries and how they can be moved to make earthquakes, which would be your unconformities. So your unconformities, things that can move rock, are because of your boundary movement. If we're talking about rocks, we then look at our rock cycle. Igneous rock is made from the cooling down of magma. Igneous rock can be broken down to sediments. Sediments can be compacted into sedimentary rock. Um, Pause right here and remember that all fossils are sedimentary rocks. They're simply rocks in the shape of a living thing. And so you never find fossils in metamorphic rock because the heat and pressure will destroy it. And you definitely won't find fossils in igneous rock because of the heating process that would destroy the fossils. The next thing we looked at is the law of superposition, which simply says that if you leave an area of rock undisturbed, left alone, the bottom will be old and the top will be young. Most of you guys get that. Where you sometimes get confused is how this youngest layer can be up higher. So keeping in mind that when a volcano erupts, that magma will burn through any rock, so it can destroy rock, which is why they destroy fossils. But when it cools down into igneous rock. So the the rule says that an igneous rock, which are a fault or any unconformity, is younger than any rock layer they disturb. In simple terms, you can't disturb something that's not already there. We looked at that multiple times, and you guys have pretty much shown a mastery of that. But keep in mind, an intrusion is simply another word for a unconformity. So anytime you see folding or earthquake or fault line, they can move very old rock down or very new rock up, which would break the law of superposition. So we looked at how fossils can tell us about how things change. Now, fossils and the rock layers as they're building up are excellent evidences of how the planet have changed. If you want to really know how the climate has changed or the weather patterns have changed over time, we are then studying ice cores. So ice cores won't tell you about how living things were changed, but they can, through their study, tell you how the atmosphere, the environment. If you're seeing super thick layers as a cold area, thin layers be a warm time period. So we can see the pattern of change over time. The next thing we can look at is if you saw any volcanic ash or dirt or dust inside these trap layers of ice, you would know that during that time frame there was a volcanic eruption or something happened to where that volcanic ash is now stored in that layer of ice. So it does give some evidence of how the climate or the environment may have changed over time. The last thing we really looked at was how can we put an age or a dating process on these fossils. So there are two types of dating. So one dating is relative dating, which does not give you a number. Let me repeat that. Relative dating never gives you a number. It simply gives you a comparison of one fossil or rock layer to another. So fossil A is older than fossil B, but there's no number attached to it. Absolute dating gives you a number, a numerical age. This fossil is between 200 to 220 million years. This fossil is 800 million years. There's a number. Anytime a question is giving you a number, that's absolute dating. If it's comparing one thing to another, that will be relative dating. Two things to remember is that with absolute dating, you can use carbon 14 for younger fossils, and uranium 235 is used for older fossils. But once again, if they give you a number, that will be absolute dating, sometimes also called radioactive or radiometric dating. As we look at an index fossil, there are some things. An index fossil, like the law of superposition, is a tool to really evaluate the relative age, a comparison age. But to be an index fossil or an identifying fossil, this is a fossil that must have lived a very short time. It must be very popular or commonly found on the planet. It must be uniquely. It's also a fossil. You are a museum or a paleontologist has absolute dated. I only can use an index fossil if I already know its age. And so the thing to remember about index fossils is that if you find an index fossil in rock A and another index fossil in rock B, and they could be on different sides of the world, but you know the age of that species of fossils, then they must be around the same age because they lived at the same time on our planet. So that's how they can be used as a comparison point. Fossils are such a good comparison point because we have this thing called a fossil record, or the evidence of change over time, starting from the oldest rock layers where we find no life into our present day or our modern day where we're finding more things. And so we can look at how life may have changed, where all the living things were really found on the water. So we know life may have started in the oceans and the water, and then over time, life may have evolved to being on land. So we'll find dinosaurs and what's not in the Mesozoic era. Um, and then up here, we'll start finding mammals. So because you don't find mammals down here, we know that we are a younger type of species or class, really. And so the fossil record, the evidence of how life may have changed over time, is a really great way of figuring out who came first, who came second, and how the planet may have changed. Because if you're finding snails and you're finding marine animals, you know that's a water ocean environment. So there are multiple types of fossils. You have preserved fossils, where the animal is trapped in ice or in tar or in armor with insects. We're also looking at our mold fossils where the imprint is left. Um, we have a cast fossil where the sedimentary rock has taken the full shape of the animal. It really works better. They have a hard body part, so this really is great for animals that had shells or bones, not so much for your softer animals. Um, Carbonization, where animal gets stuck between two rocks and simply got pressed out. So these are all evidence of how life may have changed over time, which is what fossils tell you. So this is your 2 week review. I hope you learned something from it. I hope you also looked over the questions that you've covered either in your bell ringers or doing a sample test. And I know you guys are going to do well because you've been really well prepared to succeed on this test. All right. See y'all later.